I don't know. I don't have any classes with me before.
I feel like part of it is driveway. My left. You're not driving. Yeah. Oh, there. It still works.
Still works.
They hurt them. All of them.
Doesn't it scrape your?
They literally scrape the bone down.
Pretty good.
Yeah, and then I get this one. I get this one.
You get another one.
Yeah, but when I can take off.
Is it like one of those things?
No, my mom wouldn't let me. She drove me to school. In my car.
She just let it go.
No, she just drove me to school. I literally drive home because I'm in a zero.
Oh, right.
And today I got like 2 quizzes at school, so I my mom does. Yeah.
It's easy.
I did this. I'll have time. It's crazy.
Yeah.
The only one that gets me confused is the 1 plus tangent square
That's
equals secant square.
Yeah. And then
it's 1 plus cotangent square equals cosecant square. And then it's sine squared plus cosine squared. And then the rest. And it's like r squared plus u.
I did minus.
That's it.
It's 5 or 2 minus.
I know. I didn't do it. We'll probably would have done it.
I didn't even write it down.
What did you get on the quiz? 100. Then what did you get on the quiz? Spanish is really easy.
Quiz?
No. But it's just like a whole class. We talk about teaching. Like you got her off.
Yeah, but we don't get it.
We don't. I literally talked. I talked through the entire. I talked through the entire. I take it. It's still depressing. I take it.
Really the same.
Same. Please just pick up the most positive human being in the entire world. Whenever she's just be like, you're looking cute today. Yeah, what are you gonna do after school? Are you? Is there anyone low? So no. Was I done?
That's right.
Yeah, but it's going on. My wrist is broken. I'm not even supposed to get this back. They should literally. Were you even tending out? No.
Feel like they just.
Then I would move there. You can just
one month.
pretty good nap. There's supposed to be like a 2 hours.
It was.
And we were in there for 15.
They were in the bathroom.
I don't get to get home. 15 minutes. We were just at the hospital for like 3 hours.
Lucky.
Well, yeah, but then
Well,
I'm
not lucky,
tired.
but- Do you remember?
And yeah,
Yeah.
and then Saturday.
Aha!
So, trying to hype them.
All right, guys, welcome back. So we got a 3-day week ahead of us here. We got a Monday, and then you guys have Tuesday off, Wednesday off, as far as not having to come here. Does not mean you won't have some work to do, but you won't be coming in here. So let's go ahead and real quick weekends. After that, boom, it's all verifying trig identities. All it is. All right. So we're going to spend time on this today. We'll do these 4 examples. Then I'm going to give you guys some like tips on what you might want to do when you're doing these, some like written out tips. We're going to practice some more, and then I'm going to have, I think I've got 7 problems that I'll have on the smart board for you to do, and we'll talk about those in a little bit. So let's go ahead. See about those weekends. Oh, I forgot to do this real fast. Hold on. There it is. Let's start with, he's not even here, Dylan. Okay. Silly boy. Yes, silly boy. All righty. We'll just go ahead and stay over there. Alexandria, how was your weekend? Hung out with the friends. Kevin? Hung out with friends. Krista. This was a paid babysitting? So is this a relative baby? Okay. Gotcha. Sounds good. Brady, missed you on Friday. Did nothing. All righty. Let's see here. Andrew. What am I saying Evan for? You got the, how'd you react? Any bad reaction? Now, was that Pfizer? Okay. All righty. Owen. Hung out with the family. Grace? Had orchestra. Oh, okay. Got you. Noah? Hung out with friends. Ty? How was that? Woo!
Tip City, 7-6.
Nice. Nice. Had a beautiful day for it too, didn't you? Okay, Samo. Hung out with friends. Geiger. Nothing? Oh. True. Oh, wait, True's not here. I'm sorry. Riley. Nothing. Okay, Caitlin, finish us up. A nice sunburn? What is a nice sunburn? Wow. This was Saturday, I take it? Saturday was beautiful. It was like, oh, it was so nice out. All right. Let's go ahead and look at some of these problems. So we're going to go ahead and go through and do these problems. And after we have done these, we will go ahead and talk about some key things that you can go through and try. They're not guaranteed, but there's some thoughts about good things you might be able to do when you're doing these verifying identities. Now, the reason we're doing these verifying identities is the better you get at this, the easier solving trig equations will be. So that's why we're doing this. It'll make solving trig equations easier. All right, let me actually where am I at here? Right there. I need to add a few blank pages in here and put these problems on there. So let's see here. Do I have that? Where is it? Where is my, that's not cool. This is a newer version of this, and I just, sometimes it doesn't work well. Okay, well, I'll use this instead. Actually, let's do this. Copy, Paste. Copy. Boop. So I have to rewrite them. Boop. La 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 la. And I think from what I'm starting to notice is that where our struggles are not so much the identities, but the algebra. Okay, so we need to, whoa, I'm missing something there. What was I missing? Let's do that again. That's better. Okay, so let's see what we've done here. Let's go to a full page. So remember, we're verifying. If we're verifying, again, we are not solving. So we're not moving things around as far as left to right goes. We are simply taking one side or the other and trying to change its appearance using equivalent forms. Okay? Using equivalent forms. All right, so on this one, it's your choice. You can work on the left, you can work on the right. I look at this, I'm going to work on the left, I've decided. Okay? So when I do this, the first thing I'm going to do is I'm going to split this into two separate things. One thing you have to understand, anytime you see a fraction, if I see like the fraction 5/3, I can rewrite that as the whole number of 5, the numerator, times the fraction of 1 over the denominator. I can always do that with the fraction. That's an equivalent form of a fraction. Because remember, what you do when you multiply fractions is you do what? You multiply straight across. Okay? So using that kind of a knowledge right here, I'm going to do that right here. I'm going to make this cosecant squared x times 1 over the cotangent of x. Okay? Now, I'm going to go ahead and say, okay, what would this be? Let's write this as a reciprocal identity. What would this be? Well, let's do this. What would this be as a reciprocal identity? What's 1 over cotangent x equal to? Tangent x. Okay, so I'm going to write cosecant squared x times tangent x. Okay. Give me the reciprocal identity for cosecant squared x. Yeah, Ryan. 1 over sine squared x. Give me the quotient identity for tangent x. Anybody? Sine x over cosine x. All right. Look right here. I've got 1 sine x up here, and I've got 2 down here. So what's going to happen? This one will be gone, and this will just become a regular, what? Sine x. So I'm going to have 1 over sine x times 1 over the cosine of x. What does this equal? Cosecant x times secant x. Boom. There it is. Right. Again, that's involving some fraction skills, a little law of exponents, and a little bit of identity work. Didn't even touch the right-hand side. Okay. Questions on that one? All right. Second one, here it is. Kind of like the last one a little bit, looks like. Very similar setup. I mean, look at the beginning of this. Cosecant squared over cotangent x equals da da da. Then this one is a tangent squared over secant equals blah blah blah. I think the left-hand side, I could do what? Break it into what? Could I do? Break it into 2 different pieces if I want. So one option is to write this as tangent squared over 1. Oops. times 1 over the secant. That's an option. This is what now? Sine squared over what? Cosine squared. Reciprocal identity. What is it? Cosine theta over 1. Okay, here we go. Whoop. This becomes a what now? A 1. So now I have sine squared theta over cosine theta, which is sine theta over cosine theta times sine theta. Sine theta over cosine theta is tangent theta. So I'm going to end up with sine theta times tangent theta. All right. It's the algebra, guys. I know it is. It's the algebra in this. Especially the fractions, the way we work with those. All right. Questions on number 2? Okay, here we go. Number 3. Look, there's no fractions in this one. Woo-hoo! At least not now. Okay, so which side do you want to work with? It's your choice. Left side. Okay, so the left-hand side. Give me something that I could do on the left-hand side. Any ideas? There's a lot of thoughts I could do, but what's something that you could tell me I could replace the left-hand side with? Yeah. I love that idea. Okay, now, if I'm going to do that, what happens? I need to get a common what? Denominator. Okay, what is the common denominator going to be? Cosine x. So since this denominator is not changing, the numerator won't change. Boop. This got multiplied by cosine x, so I can multiply that by cosine x. All right, so now it's 1 minus cosine squared x over cosine x. All right, the numerator. Ooh, kind of looks like a Pythagorean identity in a way. What can I do there? Yes, so if you're good at this, this could just be replaced with sine squared x. Okay, now, if that's something you're not recognizing, you can always replace 1 with what? Sine squared x plus cosine squared x. That's the basic Pythagorean identity. Any version of that is also true. Okay? Any version of this would be true. So in other words, if I subtracted cosine squared x from both sides, I would get 1 minus cosine squared x equals sine squared x. So that's why Grace said, oh, I can just replace it with sine squared x. Again, if you don't see that, you could just replace this 1 with this, and then the cosine squared x are just going to be what? Cancel out. That's up to you. Okay? So I get sine squared x over cosine x, and now it's going to be what? Sine x over cosine x times sine x, which means I get what? Sine x times tangent x. You'll know what that means. You'll learn that today, QED. Okay? That's cool. I love. These are just nothing. This is the worst one probably. They're nothing more than puzzles. These are nothing more than puzzles you get to work through. All right? Okay, so on this one, when I'm looking at it, and you're deciding which side should I work on, there's no doubt in my mind that the left-hand side, it's probably going to be easier to take a side that's complex and simplify it than to take a simplified one and make it complex. So we're going to work on the left-hand side here. Right away, my goal is to combine the two fractions into one fraction. All right, so if I'm going to do that, what is the denominator going to be, my common denominator? What's that? Cosine theta by itself? How do you get a common denominator? Always. Geiger.
So it'll be cosine times 1 plus sine.
Yeah, guys, remember, if you had something like 2/9 plus 3/7, you can get a common denominator by just taking these two numbers and doing what? Multiplying them. That's the same thing here. So my common denominator is going to be cosine theta times 1 plus sine theta. So now I look at this and I say, okay, this got multiplied by 1 plus sine theta, then so does this. So what's going to happen up here? I'm going to get 1 plus sine theta squared. Is it okay to write it like that? I hope so. There it is. Okay, plus this got multiplied by cosine theta, so I have to multiply this by cosine theta. So it's going to be what? Cosine squared theta. Dylan Dominiano. All right. I need to expand this. Multiply it out. Now, real quick, this is a review from Algebra 2, guys. If I gave you x plus 2 and I wanted you to square it, I told you guys how to do this in your head. How do we do that? Who remembers how I did this in my head every single time? Because I did not write it out in FOIL. I did not ever do that for this kind of a problem. You remember, Brady?
You like squared one of them, doubled the other one.
Yeah, you squared the first term. You multiply those and double it, because outside, inside will be exactly the same. And then you square the last term. That's how you do that in your head. Instead of going x plus 2 times x plus 2, f, or outside, inside, last, combine like terms. No, if you're squaring a binomial, do it in your head. So right here, this is going to give me 1 plus, multiply and double it, 2 sine theta, square it. Boom. There's the first fractions numerator. Plus the second one. All over the denominator. Okay? Whoa, look at this. Sine squared plus cosine squared is 1. And 1 plus 1 is 2. So the numerator becomes 2 plus 2 sine theta over what? Cosine theta times 1 plus sine theta. G, C, F in the numerator is what? 2. So I get 2 times 1 plus sine theta over cosine theta times 1 plus sine theta. Oh my goodness, the 1 plus sine thetas will cancel out. Now, I'm left with 2 over cosine theta, which is 2 times 1 over cosine theta, which is 2 times secant theta. Okay? Looks easy, doesn't it? Always looks so easy. So, does anybody notice anything about these problems? What kind of how what I do? Like, so what's the first thing you've noticed on all of these problems? Like, have you noticed anything about them at all that they like that I've kind of done to them? What, Owen? Oh yeah. On number. Oh, okay. Let me go back and hold on. Yeah.
So, the second to last step where it was from 2 plus 2 sine theta, and they would do 2 and 1 plus sine. Where did this go? That makes sense.
This two?
Yeah.
I factored it out. I factored out the two. That's the GCF. Okay. Does anybody notice anything about these though? There's something I kind of do on a lot of these problems. Ryan, what do you think?
Well, first you like tangent, you get like sine over cosine.
Uh-huh.
You expand like I don't know how to explain it.
I think the first step you do is you make sure you're working with the same denominator so that you can manipulate it all together instead of manipulating one half and then the other half.
So anytime you have fractions, you want a common denominator usually. That's true. Okay, that's very true. I want everyone to look at this one right here. At this point right here, everything's in terms of what on this left-hand side? Sine and cosine. Look here. At this point in time, everything's in terms of sine and cosine. On this one, right here, everything was already, at this point, I made it in terms of, this one's just all cosine. I didn't have any sines to use. And this one was already in terms of sine and cosine. Why is that? Because sine and cosine can be used for themselves. They can be used for cosecant, they can be used for secant, they can be used for cotangent, they can be used for tangent. All of the remaining four are all made of sines and cosines. And sine and cosines are the ones we feel most comfortable to work with. So one trick is to turn things into sine and cosine. Okay, that's kind of one of the things we do. So let's go ahead and we're just going to go through here. And I'm going to tell you, these are kind of like, I don't want to call them tricks. They're not tricks, but they're kind of like the ways of going about verifying, okay, identities. So here we go. We already have kind of talked about this. The first thing is you work with one side of the equation at a time. Now, usually I can work on just one side for the entire time. But there is nothing wrong with working on one side, getting it to a point, and then taking the other side and working on it and making it look the same. That is okay. We haven't had one like that where we had to do that. But you're allowed to do that. But you only work on one side of the equation at a time. Remember, you're not moving things from left to right. Okay? You're not doing that. You're not solving. So you're not going to say, oh, I'm going to add 12 both sides. This is not solving equations. Okay? So you work on one side of the equation at a time. And usually, the more complex one is the one you want to start with working on. Okay? Second thing. Oh, we've done a lot of this. Look for opportunities to factor an expression. We've done greatest common factor. Add fractions. We've done a lot of that. Square a binomial. We just did one like that. Or create a monomial denominator. In other words, those fractions where I separate them and I make a monomial denominator like sine theta. So it's tangent squared over sine, and I get tangent squared times 1 over sine theta. All of these things are helpful in changing an appearance without changing value. Okay, these are all ways of changing things, how they look without actually changing their value. Okay, that's a key thing to be able to do. Third one, here we go. Look for fundamental. Woo-hoo. We know what these are. One more little bit down here, I know I do. Here we go. Look for the opportunities to use fundamental identities. We just had a quiz on those. Note which functions are in the final expression you want. Sines and cosines pair up well. We just talked about that. Every one of those last problems I did, I used sines and cosines because they pair up well. Okay? As do secants and tangents and cosecants and cotangents. Now, why do I have this? Why do sines and cosines pair up? Well, I told you why. Because all the four other ones can be made of sine and cosine. But it's also because the Pythagorean identity of sine squared plus cosine squared is equal to 1. The reason secant and tangent go well together is because 1 plus tangent squared theta is equal to secant squared theta. And the reason that cosecant and cotangent go together well is because of 1 plus cotangent squared is equal to cosecant squared. Those things match up well together. Okay? They match up well. Sines and cosines are the ones you use a lot of. Okay. 4. So there's this one right here. If the preceding guidelines do not help, try converting all terms to sines and cosines. And that's what I said. Everything can always be turned into sines and cosines. Guaranteed. If you cannot do it as secants and tangents and cosecants, cotangents, sometimes you can. If you can't do that, give it all in terms of sines and cosines and go from there. And the last one is the most important one of all, actually. The last one is the most important one of all. Try something. Try something. Even making an attempt that leads to a dead end provides insight. This is the idea of intelligent failure. Intelligent failure is what inventors do. That means trying, and when it doesn't work, they say, well, now I found a way it doesn't work. This is good. I've learned something. I will try something else. That's what this is saying. Okay? Failing towards success is what that idea is. That's how you get better. Right? Again, you may not have to do all of these things, but you should always, at first one there, working with one side of the equation at a time, that is always true. You have to do that. Okay? All right. Now, all we're going to do here in a second is some practice. And then I'm going to give you problems to try again today. Okay? The problems that I give you today to try, I will actually post those online for tomorrow, so you can check them. You can check them tomorrow. Then on Wednesday, I would expect to see an extra, maybe, I don't know, 4 or 5 show up online for you to try again. So tomorrow you won't get any new ones. Tomorrow I'll just be checking the ones you do today. Wednesday, you will get a new set of maybe 4 or 5 of them. Then when you come back on Thursday, we're going to go over any of those you want. We're going to review, because on Friday, you're taking a verifying identities quiz. Taking a quiz on this on Friday. And I will tell you right now, just so I don't forget, that quiz on Friday is set up where I can't remember how many I put at the top. I think I have like 8 at the top. And you choose either 4 or 5 of the ones you want to do and you do them. So you don't do them all, but you can look at them and say, ooh, I like the one, number 1, I like number 2, 3 is crap, I'm not going to do it. I mean, you can choose which ones you want to do of the ones I give you. Okay? So I'm going to make it a little bit nicer for you, where you have a choice in which ones you want to do. Okay? All right. And I'm going to post everything here online tonight as well. So it'll all be there. you can go back and look at any of the past examples you want to. And it's actually not just today's, it's Friday's is on there as well. This is the same thing. So I'll post all this later on today, and you can check those tomorrow, Wednesday, as you need. Okay, so right now, we're just gonna go ahead and do some practice. Okay, so here we go. So what I want you to do in this one is I want you to first derive a strategy. I want you to think before you write. I want you to look at it, and I want you to think about what you might want to do on this one. Then I want you to try verifying it. So don't just start doing stuff. Think about it a little first, and then go ahead and try it. That's good. Let's try this. Let's see if that's la 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 la. That one's good. That one's good. 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 Those are all newbies. And then this one's sine tangent. Okay, this one, we're doing this one right now. Okay, good. All right. What do you guys think? What's the you think we should do on this one? Ryan's the one that's got a thought on this one? Okay, Ryan, what do you think?
Okay, so what I did, I put everything in fraction form.
Okay.
So I did sine over 1.
Okay.
Times sine over cosine.
Got it?
Plus cosine over 1.
All right, so you changed everything to sines and cosines, basically what you did. Love it. So here we go. So we got sine theta over 1 times sine theta over cosine theta plus 1, plus cosine theta over 1. Notice I don't keep writing the right-hand side down. I'm not going to keep doing that. I just leave it up there. Okay. So I guess I could take these two and make them one fraction now. That's easy enough. This just gives me sine squared theta over cosine theta plus cosine theta over 1. Okay, we have fractions. I don't like having two fractions. So Ryan, what should I do?
Just multiply the right one by cosine theta.
Yep, this is the one you have to get you have to multiply this by. Basically, you're doing this cosine theta over cosine theta. So I'm multiplying it by 1. I'm not changing its value. So I get sine squared theta over cosine theta plus cosine squared theta over cosine theta. Now I add the numerators and I get sine squared theta plus cosine squared theta. Yeah, which is going to be what? 1. How beautiful will that be? Because that's going to give me 1 over cosine theta, which is indeed what? Secant theta. And then we put these important letters, QED. QED. Beautiful. All right? Oh, you're going to find out. I got a slide on that. I got a slide about that here in a second. All right. Questions on that one? Anything we did? Using fundamental trig identities. All righty, here we go. Again, drive a strategy, and I want you to verify it. Okay. And I want somebody, when they're looking at this, would somebody please tell me anything that right away you look at and you say, I actually like something about what I see right now.
I like that it's the same color, the same, I forget what they're called, but the same thing as the parentheses, except it's +1, -1, because that factors out.
What do we call those? A plus B and A minus B are called, they end up giving you a special thing, but they're called conjugates. Remember that? And the product of conjugates always gives you a difference of 2 squares. Okay? Which means you don't get 3 terms, you only get 2 terms, which is nice. That's something I immediately see in this problem. Okay? So go ahead, try that one out. La, 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 la. This, that, this, this. Break time. Break time. Break time. I'm taking a break.
Yes, because that would be minus sign squared. They yeah, so my school, I can't fix it. Yeah. She said that. Yeah, it's not that. So then I distributed that to both of those. So then it would be sine squared x times cosine minus the sign.
Because I'm not gonna be there.
It's raining.
That's what I'm saying.
But then, yeah.
I don't wanna know your.
Well, and then I did, so the OC kids were,
That's
I read that 1 hour song, so that you can't fill out.
Damn.
Why would you get agree?
Because he's done.
If you cancel out. Instead it's just one bit.
How did you got it so close. Oh my.
Dude, how you did that? It's crazy. One person. We're gonna pay out the line.
No, I'm not saying.
I don't know.
No, yeah, yeah.
Did you finish your essay?
Yes.
When you turn it in?
What?
When you turn it in, 1:30?
Just about. Sounds about right.
Oh, yeah.
You that good, right?
I don't know, just what? I heard that. Finish that sentence. I dare you.
And then this
I know dog dare you. I want you to go to the snacks. I'm better than sleep. I can see what they're. Yeah. Are you sure?
Yeah. Yeah. Okay, right. My right hand.
You learn how to light.
I'm so terrible at trying. I already made more. She's gonna let me type out all the answers.
Or just say you don't.
And so, and with my German teacher, you're just asking her something. Well, it's already late. They did it so much. I don't know how to do it again.
You weren't even still.
You want to mulch Wednesday, May 12th? It was a shock. Did you get it?
No, I
25 an hour?
We get paid like so much. I already agreed with 15 and told my feet in. I don't know his name. Literally in my phone, his name is
No, this is my first one. No, this one.
I think Wednesdays we can just do. A couple people that want me to do meeting. This guy's a baby. Just because you guys carry the only even budget I set up all this stuff. You just gotta go on it and
Don't even know the elevator.
yeah, it's like you go for like 10 hours straight.
That's what it was, an hour straight.
And then didn't finish all the lines. And I didn't do anything. I just sat at home. So I couldn't.
I worked 10 hours I got home at 9 o'clock.
Like,
I got home at 9 o'clock. And I had to wake up at 7 o'clock.
and then he mowed 3 yards. And he skipped 2 yards. It would be so much easier if I was mowing.
Well, look at you guys on Tuesday.
I have a bit. Gosh, I actually put it on.
Or he's gonna mulch with me.
Well, it's Thursday. I'm hoping that my arm heals up enough for it.
So what do you guys do? You're like just like
No, we put on this, there's like this hole next to it, all the four people we have, and then we put some hat on them. So if you want to go in your yard, just call me, I've got like 20 yards.
Oh, so you get an atom equals to atom.
How much what?
An atom.
Oh, you literally just, it's like Instagram, you make a post.
Well, it's big enough, it's just.
Yeah, we also made Facebook bigger. We named it SOU here. I think we should do it big S. This is no BS here. Right? That'd be sweet.
Sam, hurry up with your name. Then that's your model.
No BS.
But your name's BS.
Right. That'll just be fun.
Great emotion. Hurry up.
No, but we just set it up where we're gonna have 4 hours Wednesday, 4 hours Saturday, 4 hours.
It takes too long. So.
Well, I also work at One Lincoln Park now, and at 2. 28 hours, 16 hours.
There's too many hours.
It's terrible.
You mean
850 an hour. Just sit in the back and do nothing.
Just saying.
where you at?
Yeah, it is. But the majority of the time, everybody's just sitting there. I literally canceled my shift because I had 2 shifts. This weekend. It's not serious at all.
Oh yeah, oh yeah, oh yeah, oh yeah. All righty, talk to me. We're gonna start by multiplying, you think? So here's the thing. See, this is where somebody could be like, not making a good idea. What if somebody said, oh, I'm gonna start by distributing sine squared x through? Would that be a good first step? No. Could you do it? Legitimately, is it okay to do that? Yes, but it'd be a poor choice. So this comes down to making good choices about what you're gonna do too. So, boom, we're gonna start with that. So we get sine squared x. This is going to be still in parentheses because I'm multiplying this by this product. Here I get cosecant squared x minus 1. All right, now, this should look kind of like a what? Pythagorean identity. There's a Pythagorean identity that has a 1 and a cosecant squared in it. And that is 1 plus cotangent squared x equals cosecant squared x. I want you to look at this. What is this going to be equal to? Cotangent squared x. All right. Now what? What should I probably do with this? Use, yeah, right, in terms of sine and cosine. So here we go. Sine squared x times cosine squared x over sine squared x. Whoop, whoop. Cancel, cancel. Now here's a time where somebody might say, oh, this equals, I know this is equal to what? Cosine squared x, right? If I wanted to, I could stop working on the left and just say this is cosine squared x, and that is okay at that point in time. I was only working with one side at a time. I could have just stayed here and said, oh, this is the same as 1 minus sine squared x, and been just as good. Yeah.
So I distributed sine squared x.
Okay. You could. Did you make this 1 over sine first?
That was the same, but then like the second.
Oh, here you distributed it through.
Yes.
So did you make this 1 over sine squared? Yeah, I mean, you at that point you have options. That's okay. And he's saying right here, he took sine squared x, and then he made this 1 over sine squared x minus 1. Is that what you're saying you did?
So I distributed, but then I did, so then I had, after I distributed sine squared x times cosecant squared x minus sine squared x. And then,
So you didn't change this right away like this.
correct.
Okay. Did you change it afterwards?
Yeah, then I did sine squared x over 1 times 1 over sine squared x.
So really, that's what I'm going to do right here then. If I'm just doing it in the same idea, I'm just doing those two orders flip-flopped, is all I did. Because now he's saying distribute this through. So here, you're going to get sine squared x over sine squared x minus sine squared x. This is 1 minus sine squared x. Now look, is that exactly the same? Oh my goodness, it is. It's the second way of doing it. Options about what you want to do. Right? Try it. Those are alphas. If you don't like them, you can use x's. I don't care what you put there. That's the Greek letter alpha. Hello. La 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 la. You have any questions? Anyone ask? We'll do it then. a little bit.
Is that?
We multiply fractions, denominator,
So you add.
right. What do we have, sign what? Just the first one.
Third.
Okay, yeah, that'd be right then. Oh, that's a little better with sunlight. Oh, I don't know what I see right away on this one. You guys ever seen that, like, name that tune? I can name that tune in this many, whatever it is. You ever seen that? No. I could verify this identity in 1, 2, 3 steps.
Oh, could you just cancel it out?
I can verify it in 3 steps. Doesn't mean you have to. That's the shortest, looks like to me. Brady's looking like, what? So, I'm curious, can anybody tell me what your first step was then? Did anybody do the whole, I mean, how many of you are working on the right-hand side? Let me ask you that. Show your hand. I mean, I would hope that that's probably where you're at. Okay. So, if you're on the right-hand side, what was your first step? Did you change everything? So you how many of you did everything to sine, cosine? Nothing wrong with that. That's a completely fine thing to do. Okay. Here's a step. This is one where you don't have to do that. On those 5 things I gave you, one of them was factoring. What's the GCF on the right? Yeah, there's 2 terms. Look at them. What's the greatest common factor? Cotangent cubed alpha. Okay, so I'm going to factor it out. That's a Pythagorean identity that's been manipulated. That is nothing more than cotangent squared alpha. But this again, you have to start looking at things through a lens of all those things you've been taught: factoring, multiplying, fractions. And I didn't even start with an identity. I started with an algebraic skill there. Okay, so that's what we have to do. We have to start looking at it and thinking, wow, what could I do to change the appearance but not change the value? And it's either replace with identities that you know are the same, or algebraically do something that is allowed. Okay? All right. Here we go. Next one. Oh, here, you want to know what QED was? I forgot that's where I put it. Here we go. It's a Latin phrase. It's the letters for a Latin phrase. Who's our Latin students in here? Anybody? Right there. How do you actually say this? You know? Yeah, quod erat demonstratum, okay? Which stands for that which was to be demonstrated. So when you get done with these proofs, if you put QED, you say, hey, I've shown what you wanted me to demonstrate. I've shown it to you. Okay? It's just something that a lot of people will do that do these kind of problems. If you don't like that, you can always just write this instead. This is what I used to write. And that means boom, bam, slam. Which is how I like to finish every fun problem. Boom, bam, slam. Okay? You can put QED, boom, bam, slam. That's your choice. I like them. All right, here we go. Verify it. All we're doing is practicing. Verify it. Thinking you could probably do this one in 2 steps. You guys see that? You don't see 2 steps? What can I replace it with, guys? What else? Okay, I can replace it with 1 over cosine squared. Yep. What else? One plus tangent squared beta. So you don't always have to change the signs of cosines. Anytime you see secant squared, cosecant squares, tangent squares, and cotangent squares, you have to remember you have those Pythagorean identities to work with as well. Right? So doesn't mean if you go the other way, you'll get there. It's just maybe a longer path, which is fine if that's what you're comfortable with doing. But it may not be that you always have to do that. All right, great. Boom. Next one. This is one of those identities that I'll get right now. The one you're going to use on this most likely is the one that we learned on Thursday. We don't seem to use those as much. They're still important. How much to replace that with? Cotangent x. All right. Cosine over sine times 1 over cosine. 1 over sine x, which is cosecant x. So knowing the identities is very important in this. Knowing those identities that I wanted you to memorize, knowing them makes this a lot easier. If you don't know your identities well, this gets really hard. So it's the identities, but it's also the algebra skills together. We're putting two things together here. Looks nasty, doesn't it? Looks pretty nasty. Okay. La la la. La 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 la. I'm going to suggest working on the right-hand side, maybe. Doesn't mean you can't. You can work on the left-hand side if you want. This one's a little bit more complex, guys. What's like the first thing you notice about this that's different than the other ones? Yeah, there's two different angle variables. This has got an X and a Y, which makes this one more complex. Okay. So I'm going to tell you on the right-hand side, put everything in terms of sine and cosine. I'm just going to tell you that right now. On the right-hand side, put everything's in terms of sine and cosine. Hopefully everybody has this written down. I'm going to bring this over here real fast. I'll put it back in a second. Let's do this. Let's, oh, nope, didn't want to do that. Let's go full screen. Let's add shape. let's see. Let's get to this. Let's get rid of that. And let's do this. Okay, so I'm going to go ahead. So have you guys all changed to sine cosine on the right-hand side, the first step, hopefully? I'm going to go ahead and show you what you should have if you've done that. So I'm going to put that back up on the board. So let me, real quick, let me do it this way. Doop, doop, doop. Oh, my air just clicked off. Yeah, it's back on. All righty. So tan x is going to become sine x over cosine x, and tangent y is going to become sine y over cosine y. And this is going to be 1 minus sine over cosine x, and this is going to be the tangent. So it's going to look like this. This first step should look something like this. All right? Now, here's what I want you to do next. I want you to combine the two fractions on the top. Okay? And I also want you, so you're going to have how many fractions in the numerator, in other words, of that fraction? 1. I also want you to get to the bottom to be just 1 fraction as well. Okay? So I want you to take the top, turn that into 1 fraction, take the bottom and turn that into 1 fraction. That's the hint. This. So what's my two fractions in the top? When I try to add them together, what am I going to have? The bottom, so the denominator is going to be cosine x times cosine y. Okay. What's this numerator going to be for this fraction? Sine x cosine y. Then this one's going to be sine y cosine x. Okay. Now the denominator, the first thing I have to do is actually multiply these. So I get what? 1 minus, let's take the purple color here. I get 1 minus sine x sine y over cosine x cosine y. You agree with that, I hope? If I want to make, so now, if I want to make this 1 fraction, what am I going to turn 1 into? Yeah, over itself, right? So here we go. Let's go to this next step. I'm going to, whoa, okay, didn't mean for it to go that large. How many times? Okay. I'm going to put my blue fraction bar as this one right here. Okay, so let's take care of the numerator real fast. What's my numerator going to look like? It's going to be 1 fraction. The denominator is going to be cosine x cosine y. And the numerator is going to be what? This plus this. Okay, denominator. We said we're going to make this cosine x over cosine y. Cosine x, cosine y, my bad. Cosine x, cosine y over cosine x, cosine y minus sine x, sine y over cosine x, cosine y. So now, my numerator doesn't change. Sine x cosine y plus sine y cosine x all over cosine x cosine y. The denominator now is going to be cosine x cosine y minus sine x sine y all over cosine x cosine y. Okay, before I even do this next step, do you notice anything about the red fraction and the purple fraction? They have the same denominator. So in other words, it's like this. A over B divided by C over B. It's that kind of idea. Okay? Now think about what this is going to do. This is A over B. If I divide, I can do what with this? Flip it in, multiply it. What's going to happen then to these? So when you see a fraction over a fraction and they have the same denominators, those denominators are going to always cancel. And I'm going to be left with A over C, which means I'm going to be left with this sine x cosine y plus sine y cosine x over this. And if you look up above, that's what they wanted. That has a lot of algebra, fractions, working with them. That's less working with identities and more being able to just combine things together in a correct way. All right. Yeah, probably don't like that as much, do you? I'm sure. As soon as you start getting fractions and fractions over I mean, it looks terrible. You have to be, here's the first thing is, you can't do it in your head. The better you write things down, the easier it is if you're having struggles for me to say, here's your mistake. Okay? Don't try to skim. Write it down. Okay, write it down. All right. So here we go. These are the problems you're going to do tonight. Now you'll notice they're numbered in blue 1 through 7. In red, you'll notice they're numbered in different order. Okay. I numbered them. The ones that I have numbered in red is, I believe, how they go easiest to hardest. So like I'm saying, I think number 6 is probably the easiest one on here. And then I'm saying I think number 1 might be the second one. And then I think that number 4 is the next one. So I've got them kind of numbered by difficulty level, I believe. Okay. So you need to write these down. This will be posted online as well, because I'm going to post the notes online. I told you that, but I would write them down if you could. And these are the identities you're supposed to be doing. And tomorrow the answers will be online for you to check them. Okay. And tomorrow, when you look at the answers, it may not be the same route you have chosen to go. That doesn't mean what you were doing was wrong. I'm just going to do it one way, and that's it. Okay. So that's it. That's your assignment for tonight. You check them tomorrow, Tuesday. Wednesday, you'll find a new assignment, and then that Wednesday assignment will go over on Thursday when you come in. Okay? Oh, yeah. Good.